Welcome to this meeting of the Environment Committee. It's Tuesday, April 24th, 2018. The first item on our agenda is an approval of the agenda. Do we have a motion?
So moved. Sure.
Motion and second. All those in favor, please say aye.
Aye. Aye.
Opposed? The agenda has been approved. Next on the agenda is the approval of the minutes. Are there any changes or corrections from the meeting last? If not, is there someone who will approve the minutes?
So moved. Second.
Taking turns here.
Yeah.
All those in favor, please say aye.
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 Opposed? The minutes have been approved. The first business item we have is 2018-108, and it's a contract for dewatering. And Mr. Tierney is going to walk us through this. Welcome, Mr. Tierney.
Good afternoon, Madam Chair and council members. My name is John Tierney. I'm the mechanical maintenance manager for our wastewater treatment plants. And I'm here, my subject is the contract for the Alpha Laval dewatering centrifuge equipment at a few of our locations. The background behind it, we have 10 full centrifuges and 2 rotating assemblies that dewater the product that we process. We've come to the end of our contract life. It's very critical equipment to our business. Without this equipment, we'd be in dire straits. So the rationale is these centrifuges are proprietary to Alpha Laval. They were designed and manufactured according to the OEM specs and tolerances. Parts and services can only be provided by the OEM vendor, Alpha Laval. Where non-OEM parts are available or we can purchase those, we use the purchasing, or we purchase them according to the competitive sourcing procedure. But it's very few. We found that some of the parts that we get elsewhere are inferior to the components in the Alpha Laval. But we do our best to source other locations when we can. So the Thrive Lens analysis, this action advances the Thrive outcome of stewardship. So we want to be fiscally responsible with our funds, and by using the OEM parts and services, we are more reliable with our equipment. So the proposed action is that the Metropolitan Council authorize the regional administrator to execute the sole source contract for the dewatering centrifuges at Metropolitan Council wastewater treatment facilities. The original equipment manufacturer, parts and service in the amount not to exceed $2,500,000 over a 5-year period, beginning next month and run through April 2023.
Thank you. Are there questions for Mr. Tierney? So how much dewatering do we do?
Well, everything that goes to our incinerators at Metro, we dewater. We burn approximately or up to 300 dry tons a day. So all that product goes through our centrifuges, fills our cake bins, and then eventually gets pumped to our incinerators.
And this is not to exceed 22.5 million. So is it possible that it would come in less than that?
Well, in the past, we've broke pretty even. Our 5-year periods usually come. We're right at the dollar right now. At the end of this 5-year period from initiating the first contract in 2014.
Interesting. So you guys have got it down to the penny practically, huh?
Yeah, we do pretty good. In fact, I just recently toured a few different other incineration facilities that have a lot of the similar equipment. We do far more maintenance to our own equipment than other places do. So we have a really good group really intelligent, smart group that takes on issues on their own and tries to get to the bottom of them before we call in, outside help. So we do a really good job.
That's good to hear.
Yes,
That's very good to hear.
very skilled individuals.
So the proposed action council members is that the Metropolitan Council authorize the regional administrator to execute a sole source contract for dewatering centrifuges used at the Metropolitan Council wastewater treatment facilities to Alpha Laval to provide original equipment, manufacture parts and services in an amount not to exceed $2.5 million over a 5-year period beginning May 2018 through April 2023. Is there a motion?
I'll move that.
I'll support it.
We have a motion and we have
Oh,
a second. We have 4 council members here on the committee. We have 2 that speak up. All those in favor, please say aye.
Aye.
All those opposed?
Just leave it hanging.
Well, we'd be more than happy to start talking if you'd like.
Madam Chair, I wasn't here for the whole discussion, so that's why I left it to
The
my
motion
colleagues.
prevails. All those in favor, please say aye.
Aye.
Please do that. All those opposed? The motion prevails. Thank you, Mr. Tierney.
Yeah, you can.
Just teasing my council members, the women are doing all the work here.
Wow.
Oh,
Wow.
That'll get you going.
Okay. Well, we'll let you do the rest of the work then.
The next item of business is 2018-109, proposed policy amendment to the Water Resources Policy Plan. Janine, you must be getting tired of telling us this story, but we will listen to it again.
Madam Chair and members of the council, thank you for taking the time to hear about this one more time. As you know, we oftentimes go through a pretty long process with policy plan amendments. So this is the Water Resources Policy Plan Amendment regarding wastewater reuse. And the slide before you just kind of shows you the long process that we have gone through beginning in March 22nd of 2017, where we started the policy task force to consider wastewater reuse, until a year later, where we are asking you to consider amending the Water Resources Policy Plan that would include the recommended language. So as you know, we, through the task force, developed 3 alternatives to the water reuse policy language. Alternative 1 identified no regional cost share. Alternative 2 identified a regional cost share based on economic and environmental benefits. And alternative 3 recommended a regional cost share based on wastewater system benefits only. And we vetted these proposed policy amendments at 2 workshops and a public hearing, and I would suggest to you that we had pretty good attendance at those meetings and had quite a bit of public comment. So the conclusion from the public comments was that the comments that we received were reflective of those of the task force, where we had varied opinions on whether or not there should be a cost share. That was consistent with the task force findings and also consistent with previous council discussions. The second thing is that the council's wastewater reuse customers, the council's wastewater customers, which are the cities, can support an alternative 3 or have provided comments on why they would want to see council proceed with alternative 3. And then for a pilot program, projects under consideration could proceed equally under alternative 2 as well as alternative 3. And then finally, that given the council's commitment to collaboration and not competition overall, and particularly in its wastewater reuse activities, staff recommend alternative 3. So the recommended policy is that staff recommend a wastewater reuse pilot program with a regional cost share component based on wastewater system benefits only, which is alternative 3. And the specific language was in your business item. We would amend the Water Resources Policy Plan, which is this document that would include that language. And that recommendation reflects listening to public comments as well as those of our customers. the Thrive framework for a commitment to integration, collaboration, and accountability. As you know, we also received some detailed comments from the Department of Natural Resources, and we included those in the policy language. And then again, you can see the language itself in your packet. So this is our Thrive lens. The Water Resources Policy Plan amendments identifies working with our partners, which we did with our task force as well as our outreach, maximizing regional benefits from regional investments, so getting the best use of our wastewater system by enabling us to support regional growth in areas where water sustainability may be a challenge, and then finally providing efficient, high-quality, sustainable wastewater services. So the proposed action this evening is that the Metropolitan Council adopt the recommended wastewater reuse related policy amendment to the Water Resources Policy Plan that includes a regional cost share based on regional wastewater system benefit only.
Thank you, Janine. And I really didn't want to make light of it. I think one of the things that, especially that first slide that you showed us, is the thoroughness and care with which this change has been made, the amount of input that we have received, and the time we've had to reflect on this. And I think that bodes well that, you know, often we get accused of maybe mission creep or things, and policy changing is a serious business, and it was taken very seriously.
Thank you.
So with that, Councilmember Lutovsky.
Thank you. Yeah, I just have two kind of comments, issues. I'm going to support this today, but I do wonder, some of the feedback was to do a pilot pilot project, and I probably missed it, but in the business item, where does it suggest that it's a pilot?
Okay. So the pilot project is, let's see, identified.
Because there's just a lot of language just about how the council's going to go about deciding which project it's going to work on, but I don't see how it's.
Madam Chair, members of the council, in your business item, under the section called Finance, it's actually the last line that says the council shall report about the wastewater reuse pilot program funding at council's annual budget outreach meetings. And then prior to that, on page 4 of the business item, it basically suggests the council shall use a cost of service, case-by-case approach to wastewater reuse in cooperation with partnership with local communities. And further on, it talks about provided that the cumulative regional cost share shall not exceed 0.75% of the total annual municipal wastewater charges. And then it goes on to talk about how those criteria would be suggested. So the pilot program is really embedded in the language of the policy plan.
And so does that mean we're just looking at the one right now, the one project?
Madam Chair, members of the council, we are not looking at, we actually have a proposal of one project before us, but we believe that this pilot program could accommodate up to 3 projects.
Okay, great. And then just one more
Go ahead.
issue. I understand regional benefit and all that, but the geographic locations where we can do projects with wastewater is located near the treatment facilities, which are in just specific places, right? It's not, so not all communities are actually going to be able to do a project that takes advantage of this opportunity. And so you can see a scenario where parts of our region are going to be charged, but they're not going to get as much of a localized benefit as those that are located, where the wastewater treatment facilities are. And that's in my mind, and I don't quite know what to do about that, but certainly is something I'm going to be thinking about as we come back with the results of this particular project.
Madam Chair, if I could, that specific issue was talked about at length by the task force, and I think generally speaking, people see that as an issue with a regional wastewater system that that we succeed as a region, and sometimes there might be more direct benefit with one initiative than the other. But if the overall region is benefiting from a well-functioning wastewater system, that is a positive for the region in and of itself. But you're absolutely correct. There are some areas of the region that will benefit more directly from this program than others.
Are there other questions or comments? If not, the proposed action is to adopt the recommended wastewater reuse related amendment to the Water Resources Policy Plan that includes a regional cost share based on the regional wastewater system benefit only. All those in, is there a motion?
Come on, boys.
It's your guys' deal today. Just sitting over here.
You guys have been doing such a great job.
Yeah.
Motion, Madam Chair.
Thank you. Is there a second to the motion?
Did you move?
I didn't. One of those guys did.
Oh, no seconds now?
I can't make the first and the second.
Yeah.
So I already made the
Protest
I'll
vote,
second
so-
the motion, Madam Chair.
Thank you. We don't have to make an issue out of this, folks. I was just teasing. All those in favor, please say aye.
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 Opposed?
Making all motions.
The motion passes. Thank you, Janine. The first information item we have is an evaluation of Metro sewage sludge incinerator ash. We have two people with us today, three people. Larry Rogacki, Dr. Carol Rosen, and let's see if I don't have the third name.
Madam Chair, committee members, last February, you approved us to enter into a 3-year research agreement with the University of Minnesota to look at the appropriateness of using ash from our incinerators as an agricultural fertilizer. And so 1 year has been completed, and we thought this would be a good opportunity to share the results of that year and then the plans for this coming growing season. So Dr. Carl Rosen, he's the principal investigator, and Persephone Ma, she's the graduate student, and just sort of an information item to give you an update on what what we've been finding so far.
Okay, great.
Thank you and welcome both.
Thank you, Madam Chair and council members. Thank you for the opportunity to provide you with an update on our project. As Larry mentioned, we've been looking at the ash as a fertilizer amendment for crop production over this past year. Next to me is Persephone Ma, and she's the graduate student on the project, so that means that she's done most of the work. So just to give you a little bit of idea on why we did this project and why it was funded, is that about 38 tons of ash are produced per day during incineration. And the ash, based on analysis that we've done, contains significant amounts of phosphorus, which is a limited natural resource and something that's needed for crop production. Currently, the ash is disposed of in landfills at an additional cost to the Met Council. And so we wanted to see if we could recoup some of that. And based on the analysis, we found that the ash contains about $2 million per year of phosphorus. If you were to buy that phosphorus, it would be about $2 million per year. That doesn't even include the landfill costs. So there's some substantial money in that ash if we could find a way to reuse it. This is not a new project. We've done research over the years. Back in the 1980s, early 90s, we did some work with some of the Met Council ash as well. That ash had a lot of metals in it, much higher than what the ash is right now. And so that was tabled for quite a while. We renewed there was renewed interest then in 2014, and we did some greenhouse studies and with some of the new ash with lower metal content, different types of processing. And we found very positive results. So we thought the next step would be to take it to the field and do a little more detailed study. So our overall objective is to evaluate this ash as a phosphorus fertilizer source, looking at the impacts of this amendment on plant growth, crop production, characterize what it does to the soil, and also look at what it's doing to some of the microbial activity and microbial populations in the soil. That's kind of a hot area right now in soil science. So very simply what we're doing, looking at is, does it work? Does it work as a fertilizer? How well does it work? And then, are there any environmental impacts that we need to be aware of? So those are some of the things that we're looking at. So the experiments that we've done over the last year, we've basically done two. One was a kind of a laboratory incubation, what we call an incubation study, where we just put the soil in these jars and monitored what was going on over a period of time. But the main study that we did was a field study where we actually applied the ash to the soil and looked at how it affected corn growth over the last year, and I'll provide some details on that. So the treatments that we're looking at, we wanted a conventional phosphorus source. So what we're using is comparing the ash to triple superphosphate, which is a conventional phosphorus source used by growers. And the analysis of that phosphorus is 46% phosphate. That's the total amount of phosphate that's in there. And we have an additional test that tells you what the fertilizer value is. And for the conventional fertilizer, the total phosphorus is the same as what the available phosphorus is. In contrast to that, with the Met Council ash, the sewage sludge ash, it has a fairly high total phosphorus content, about 26, 27%. But the available phosphorus over what we would consider available over that first year is substantially lower. So we need to take that into account. We also looked at two other byproducts. We looked at biosolids from the Blue Lake plant, the dried biosolids, and we also looked at struvite as comparisons. But because of time constraints, I'm mainly going to focus on the ash relative to the conventional triple superphosphate. Okay, so this is what we did. As I mentioned, we did an incubation, and we put in about 300 grams of soil in a jar, and you can see that we bought a lot of quart canning jars from Target. I think we cleared out their warehouse for this study. So we had a lot of different treatments there, and we were looking at how the phosphorus was released and other elements were released, as well as microbial activity, over a 64-day period. And you can see that our treatments, again, were the conventional triple superphosphate, the ash, the biosolids, and the struvite. And we applied the ash and the conventional fertilizer at 0, which means we didn't amend it at all. It's just the natural soil. And then half the recommended rate, 1x the recommended rate, 1.5 and 2x. So we basically had those 5 treatments for the conventional fertilizer and the ash. And the conventional, the recommended rate, 1x, is based on the amount of fertilizer that we would apply to a corn crop on a low to medium testing phosphorus soil, which comes out to about 80 pounds of phosphate per acre. So that's kind of what our benchmark is. So we went a little lower than that, and we went a little bit higher than that. Okay, so these are some of the results, and what we're looking at here is available phosphorus in the soil. And what you can see with the blue bars there, that's the conventional fertilizer. And you can see as you increase the rate from 0 all the way up to the 2x rate, it does increase. You see the same trend with the ash, which is the red bar there, and but just lower amounts. And we did it. I'm only showing the results on day 0, and then at the end on day 64. And the trends are the same whether you did it on day 0 or day 64, although the values tend to be a little bit lower for the ash and the conventional fertilizer on day 64 because you're getting some tie-up just due to chemical reactions within the soil. But the good news is that when you apply increasing rates of these amendments, you're going to see an increase in the amount of available phosphorus when it's applied to the soil. So that's good. Those are good results. Just a little bit lower with the ash relative to the conventional fertilizer. Okay, so the other things that we looked at were what we call elements of interest. And these are mainly the metals that EPA has identified in their 503 rules as, if they get to a high level, they're of concern, either through causing plant toxicity or being harmful to the people or animals that eat the crops that are grown on that soil. But basically what we can say, at least from the incubation studies at this point, is that and I'm not showing all the EPA 503 metals, I'm just showing the ones that are often brought out. Mercury, cadmium, and arsenic are ones that are in the ash. We can measure them in there. But when we add the amounts in the soil to the soil, you can see that, relatively straight lines. There's not a lot of difference when you add it. And this is attributed to the relatively small amounts, even though they're being added. There's enough variability within the soil itself that you're not seeing a lot of increase when you increase that amount to added to the soil. So with all three of those elements there, we don't see any major problems showing up from the incubation study. So that again is good news. So we then took our study out to the field and grew basically a corn crop. We had 180 plots in the field, and we did this at the Rosemont Research and Outreach Center. We had 8 replications in there. We planted a popular variety of Roundup Ready corn, and we looked at soil, plant, and microbial sampling through the season and at the end of the season. Mainly just going to talk about the soil effects today. We're still working on some of the other data right now, but again, we used had those same four major phosphorus sources, and again, we looked at the 0, again, non-amended, half X, 1X, 1.5, and 2X. Those were the treatments that we applied with those 4 sources. So this is the yield results, and we did plant in what we would consider a phosphorus responsive soil, but you can see even at the very left-hand part of the graph, the 0 rate just shows that there's even without amending the soil with any phosphorus, regardless of source, there's quite a bit of variability there. And we didn't really see a statistically significant response to increasing phosphorus, regardless of what the source was. However, I can say that our yields were exceptional. 200 bushels per acre is considered very good for a corn yield, and we were getting well above that. So we have a very productive soil, even though the soil test phosphorus initially was what we would consider on the kind of low to medium side. And this isn't too unusual when you start an experiment like this, and this is one of the reasons we need to continue this over 3 years. We're going to be planting corn again on these same plots, and we suspect that when on those plots that we haven't been adding any phosphorus or lower amounts of phosphorus, we'll start seeing that response. So the good news is we got great yield regardless of the phosphorus source. The bad news is that we didn't really see a phosphorus response that we were looking for. Okay, so those were the yield results, but what's going on in the soil? Again, this is available phosphorus, and like the incubation study that we did, you can see kind of a linear increase as you increase the rate, regardless of source. You can see that we increase the amount of available phosphorus. And this was at the end of the season. So these levels would have been likely higher when right after planting. So again, this shows that the ash is a viable source and is able to provide phosphorus for that crop. So that's, again, good news. So again, we went to look at those elements of interest. The 503, I'm just going to show a few of them. One was arsenic, and again, pretty flat, even though you're adding a little bit of arsenic with the ash, there's enough variability in that soil that at least after 1 year, we're not picking up any large amounts being accumulated. Same with cadmium, a little more variability there, but again, you can see there's quite a bit of noise in the data, but the ash doesn't really stand out as being a source that's going to accumulate at least after 1 year of application. Same thing with mercury. Again, fairly flat. Maybe there's a little bit of increase in there, but it doesn't really follow the rate, and we're looking at that mainly as a little bit of noise in the data. So even when you don't amend the soil, you can see there's about the same amount of mercury in there as when we're adding those different amendments. Okay. So we also looked at some other elements like zinc, which tends to be very high in the ash. But zinc, unlike mercury, arsenic, and cadmium, zinc is an essential plant element. And so an increase in the soil is something that's actually could be beneficial to the crop. And so you can see that with the ash and the biosolids, you do get a slight increase in zinc with addition, which is what you'd expect because there's fairly high levels of zinc in this ash. We also saw the same thing with copper. There's quite a bit of copper in the ash, and we got the same thing with the biosolids and the ash as well. So even though it's increasing, we think that's actually a benefit because these are elements that are essential for plants and animals. So a small amount could be beneficial. Okay, so other data, things that we're doing. We did analyze the plant tissue, so what's in the corn grain and in the stover, the stalks. We are waiting to get that data back. We should get it back very shortly. We also have what we call these Nc2 probes, where we bury it down by the root system. What that does is it is an equilibration with the soil solution, and it will any elements that are in the soil solution will exchange with those probes, and then we can bury those probes and pick them out periodically to see what the root might see, so to speak. And so we have those data that we're looking at as well. And then finally, we're also looking at the microbial activity. As I said, this is kind of a very hot topic in soil science. We know that the microbes are, within a gram, there's a billion bacteria in the soil, in each gram of soil. And so there's a lot of diversity in there. And we're looking to see if there's any change in that diversity with these different amendments. So that's still ongoing. We are just about to start our field season finally. We were getting a little worried with all the snow, but it's finally starting to melt. And we're going to be looking at the same treatments as we did in 2017. The difference is that last year we planted all corn. Half the field this year will be corn, but the other half will be soybean. And so we're going to look and see how the treatments affect the soybean. Now, we're not applying any ash to the soybean because normally the soybean crop is following corn, isn't fertilized. You apply the fertilizer to the corn, and then the soybean follows it. So that's what we plan on doing. And then the following year, we'll be reversing the plots and applying corn and soybeans. And where the soybeans were, we'll plant corn, and where the corn was, plant soybeans. So we'll have quite a bit of data to summarize in future years. So so we hope to be planting this very, very shortly. So I think after 1 year, we can come up with some conclusions. Very simply, does it work? Based on the soil analysis, we do find that it increases soil phosphorus, which is what we hoped and expected, and that's what it does. And so it compares well with the fertilizer. How well does it work? Well, we're hoping to see more of a phosphorus response in future years. So hopefully in the next year or two, we'll be able to say how well it works. But if the plant does need phosphorus, we are confident that it will provide that phosphorus. And are there any environmental impacts? To date, after at least 1 year of application, we don't see any red flags. Particularly as related to the metals identified by EPA. And we're still looking at the microbes. That's an ongoing project, and we'll have more data on that over the next year. So I think this is our last slide. And so again, I'd like to thank you for the opportunity to present our results. I think we're making good progress, and hopefully it'll be beneficial for beneficial use of the ash, as well as beneficially helping crop production and conserving a natural resource like phosphorus. So thank you.
Thank you. Council members, are there questions or comments? Councilmember Leptowski.
Thank you, Chair. At the beginning of the presentation, you talked about how the study you did back in the 80s showed that the soil was different than the soil is now. Like why is
Okay, Madam Chair.
Maybe I got it wrong because
No, it's not the soil. It's not the soil. Yeah, there's a lot of
interest.
sorry, I probably said that too fast. It was the ash that was different, not the soil. So back in the 80s, if you recall, the ash was basically landfilled, a temporary landfill, and back at that time, the regulations in terms of what could go down the drain were not as stringent. And so the metals were quite a bit higher, sometimes magnitudes higher than what they are now. Particularly cadmium was way, way off the charts back then. So we did some of the studies because there was still phosphorus in there, so we were still looking at it as a potential use. But because of the metal content, it was tabled. And so
we're taking that out now.
So the metals are
doing a better job.
We're doing a much better job of keeping the metals down. And one thing I forgot to mention is when we went out there and did this, put the treatments on the soil for the experiment down at Rosemont, there was a reporter there from Star Tribune, and I don't know if you read it. There was a big spread in I think it was the Metro section on this particular study, and when I did receive comments, some of concerned citizens. Why are we doing this? And why are we putting sewage sludge on the land? The main concern was not so much the metals. The main concern were the pharmaceuticals that's in sewage sludge. And because the sewage sludge is incinerated, the pharmaceuticals are no longer there. So I was able to tell the concerned citizens that the main purpose of this is look at the ash, and there are no pharmaceuticals. And that really, I got comments back, that's different, because a lot of there's a lot of perception about biosolids. I mean, and the metals are one concern, but actually more of the concern are these pharmaceuticals and other organic compounds that are in there, that are in the toilet and in the drains and things like that. So it's interesting.
Did you want to make a comment?
I'll just add that part of the reason the metals are down is we've had an industrial waste program that permits industries that were discharging a lot of the metals, and so that's one way in which we've reduced the metals concentration.
I have a question. Do we have a market for, if this proves to be beneficial, would we have a market for? Would we be competitive if we were able to get rid of the ash that way?
Yeah, Madam Chair, council members, in terms of the market, well, phosphorus is a fairly expensive nutrient, and I think considering that it's just being landfilled now, I think if you could provide it for trucking costs, I think there would be a market. And not only that, one of the problems with biosolids is that there's a lot of bulk with it. When you incinerate it, you reduce the volume and you concentrate the phosphorus. And so you can actually transport it much further than you can some of the other byproducts like biosolids. So there's some advantages to doing this. The other advantage is that there's no nitrogen or very, very little nitrogen in this, so that you can put it on in the fall. You don't have to worry about the nitrogen leaching and things like that. So there's definitely some advantages to this. So I'm not really in the fertilizer business, but just knowing about fertilizer, I think there'd be some interest in it. That'd be the next step.
And then Persephone, how long have you been working on this?
Madam Chair, I think it's the end of my second year.
And how much longer will you be working on it?
Another 2 years.
Another-
If all goes well.
Excellent.
She's working on a PhD, so
I'll be
It
here
takes
for a
time.
while.
she'll be here it takes about 4 years.
Other questions or comments? Councilmember Schreiber.
Yeah, this is a little off subject, but I heard you talk about transport. I don't know why this is in my head, but is there a limit of like 100-mile limit, how far you can, I don't know why I remember that. How far can you truck our sludge, the phosphorus, the product, the end product? Let's just say we get all the green lights, we're ready to go. Is there a limitation how far you can truck from source to I don't know why there's
Madam
something
Chair,
in my
council
head.
member, I'm not sure about limit. Usually the limitation is more for the value of the product. And when you're looking at something like biosolids, you're hauling a lot of bulk. And so there's a limit to where, it just costs a lot. The further you go, the more it costs. If you're selling this as a phosphorus fertilizer and it's dried, I don't think that you would have a 100-mile limit. I think you could sell it, as to places that need it, and you're basically going to be competing with conventional fertilizer. So as long as you can compete with conventional fertilizer, you can probably ship it anywhere. I think but I'm not aware, I could be wrong, but I don't think there's any limit on where it can
Madam
be.
Chair, I could be wrong too. I might not be thinking about the right product, but I just thought there was some limitation.
Are you thinking about the waste transfer? How far people that come from that do septic systems come to?
Possibly. I thought there was some limitation, but
I'm not going to worry.
it'll come.
Yeah. I'm sorry, I can't, I'm not sure.
Well, Persephone, Councilmember McCarthy.
Please go.
Go ahead.
I just want to say I find this very fascinating that we can take our waste and our ash and possibly turn it into something that is both useful, for our crops, but also a way that we can eliminate using our ash or our waste into disposal into our landfills. So it's really wonderful that you are doing this. So it brings to mind, other than us giving you our ash, do we help fund this whatsoever? And then also in addition to that, with that kind of yield, what do you do with all that corn afterwards?
Okay, Madam Chair, council member. Okay, I'll answer the last one first. That's an easy one. The Rosemont experiment station harvests all the corn. So we just take our small little plots and we do our analysis on it. But the experiment station actually sells it on the market, and it helps support the function of the station. So they like corn experiments there. The other, I guess the answer to your other question is yes, you give us the ash, but you're also helping to fund this. There's significant funding. It's Persephone is very, very happy that it was funded, and it's funding her education as well as a lot of the analysis, which is quite expensive when you get into the metals like mercury and arsenic and selenium and things like that. So we're very grateful for the support as well.
Councilmember Reynoso?
Thank you, Madam Chair. 2 questions. One, do you tell people how that are purchasing it, how it was grown? And 2, who's the taste tester here? Because that's an important
Right.
issue.
Okay, Madam Chair, Council Member. The source of phosphorus, it is a source of phosphorus that's not going to be very there. It's always a perception problem.
Right.
You know, that's going to probably be the one thing that you're going to have to overcome is a perception problem. But I can say that, you know, even with biosolids, which has an odor, which is way worse than, you know, this really is odorless. So there are farmers that line up for biosolids because it's a free source of nutrients or very low cost source of nutrients. Most of this is not going to be used for crops that are used for direct human consumption. It's mostly going to be used, that's why we're looking at corn and soybeans. It's going to be used for crops that are going to be fed to animals or possibly even go into ethanol or things like that. So, you know, from that standpoint, the perception is not as bad. If you're going to be growing vegetables, things like that, there may be more of a perception problem, but I'd recommend using this as well as biosolids for these types of crops.
Right. You know, just to follow up on, you know, the old adage of you are what you eat.
Yeah,
Right. You know, that's the only
Right.
thing I think of.
Well,
You know, and perception is huge.
perception is probably more than anything else. The amount of contaminants that are actually taken up are very, very low based on what we've seen so far. I don't think we'll be detecting the metals to any degree, except for maybe zinc and copper, which are good because when in our vitamins we take zinc and copper in our vitamins. So why not get it from the produce? So
Additional questions? Councilmember Melandri?
So yield, you said, but did you make reference to some type of yield of the corn?
the corn, yes.
How much per acre?
Madam Chair, Councilmember. Yeah, so we had phenomenal yields last year. We had very timely rain. It was an average of about 220 bushels per acre was the average. And we had some plots that were as high as 270, which I think is almost a record in that it was just a very good hybrid and a very good year, very timely. We didn't have to irrigate this. So yeah, very good yields on lots of all the treatments, regardless of what we did, including the ones where we didn't put phosphorus on, which was surprising to us, even though the soil test was low.
So was there a difference for those areas that had the product on versus, I mean,
Yeah.
difference in yields?
Yeah,
We had
yeah.
it was a very, very wet year last year.
Yeah. So, Madam Chair, Council Member, there was no statistical difference between any of the treatments that we applied last year, which again was surprising to us. Now, it was a wet year, but this soil at Rosemont, it's kind of it's a silty loam soil in the top foot or two, but below that is gravel. So it drains very well. So we didn't really have any real excessive moisture problems in this particular field. So it was actually somewhat ideal for the corn, even though there was a lot of rain. So we're looking to see over the next year to, hopefully we'll start seeing differences among the treatments between the ones where we haven't applied any phosphorus and the ones where we have. So.
Council Member Reynosa.
A couple of questions just came to mind. I noticed that you guys used Roundup Ready seeds. And obviously they're treated. I'm assuming they're treated with some type of pest-resistant formula or whatever. Were there some that weren't treated with the Roundup Ready? And have you guys seen maybe this type of crop being treated with this more resistant to pests?
Yeah, Madam Chair, Council Member, the Roundup Ready corn is what all the growers are using. Almost all conventional growers are using those seeds now. So we selected a hybrid that was typically grown in that area. I don't know unless you're organic, and I don't think that this product would be approved for organic. So, although I mean, it could be. I don't know, but we're mainly targeting the conventional market, which is why we use the Roundup Ready corn, and it also has other pesticides coated on the seed as well. So we had, and the reason why you use the Roundup Ready is that you can control the weeds very easily. We didn't have to do any hand weeding, and neither do growers. So we're just kind of following what the growers do. And so I can't really answer the question if we used more conventional non-Roundup Ready, what the effects would be, but only a very small percentage of growers use that seed now anyway.
Thank you. Other questions or comments? Well, thank you again for the presentation, and Persephone, good luck with your work.
I think maybe next year I'll have Persephone give the presentation.
I was going to say.
Yeah, she wanted me to do it this time, so now she knows. Now she knows how to do it.
Thank you very much. We appreciate it. The last item on our agenda is the General Manager's report. Lisa?
Okay, it's spring, and while we haven't had a lot of spring rains, we've had some extended winter with snow and slow thaw, and so we are paying attention to river levels. Just to focus your attention and give you one of those historic facts, we have a record going back 124 years for river crests in St. Paul, and there's been 63 of them over that 124 years. And over 30% of them have been in the last 2 decades. So we are seeing more floods, and we are more tuned to paying attention to the river probably than ever. And with that, I've asked Larry to provide a little bit of an update of what we're looking at.
So, Madam Chair and committee members, we get a daily update from the National Oceanographic and Atmospheric Administration Office on river level in the St. Paul area. Right now, the projection is the river will continue to rise until Sunday or Monday and then level off at that. If the predictions hold, the river will be about 6-8 inches below where we have to start, where it starts flooding Childs Road. So at this point, it doesn't look like anything excessive. We did start our effluent pumps because now we have to, the river's high enough, we have to pump the water out. And so we have those running, and we'll probably have those running for a good week anyway. We have 24-hour electricians coverage. We're starting to order chemicals and supplies just in case those projections change, because based on rainstorm and where they happen and the temperature rise, they change every day. But at this point, it looks like it'll be a pretty good, won't be any significant impact to us.
It's good news. Good news.
So I can't remember what I was hearing this morning. It must have been on NPR. I mean, so they were talking about in the next week or so, I don't know if it's the Minnesota, the Mississippi. I mean, will it be above so many feet above, a couple of feet? I can't remember even what the number was, but so where are we from, so what is, give me the visual, 6 inches from Childs Road. I mean, what is that above flood stage, or is it flood stage, or?
I wish I could answer that question. I don't believe there's going to be any road closings, even in St. Paul, you know, by the railroad.
No, but I just kind of what they consider flood stage. I mean, if there's an elevation.
Right, that's the point. But do you know where they consider flood stage? What elevation? Not prepared, I'm
Right.
sorry.
I'm not going to worry about that one either.
When we hit 16 feet, I think is the trigger for putting the Child's Road access up. So that'll give you some.
What's the number?
16 feet
16 feet of above.
at the station in St. Paul where they measure the elevation,
It raises 16 feet?
right?
It's very confusing because there's feet, there's gauge elevation, there's,
Sure.
you know, it's all,
I
everybody's
was just
got
trying to
different-
remember what I heard this morning, so no, just curious.
Lakes up north still are frozen. I wonder.
Thank you, Larry.
You're welcome.
Council members, anything for the good of the order?
Motion to adjourn.
If that
Second.
is, we are adjourned.
That, huh?
Yeah, we did pretty